No. Okay, so can you hear me, guys? Okay, so let's start. Good afternoon, everybody. Okay. So what I did so far, guys, I told you our microcontroller has two ports, port A and port B, as you see here. Is that okay? By the way, in Capstone or in any future courses, maybe the microcontroller is going to have other ports. That's okay because this is just a small microcontroller. Okay, so everything you are going to see in this course, it will be the same thing. If you go for a bigger microcontroller, the only difference is that here we have only port A and B. Okay, maybe other controller they have A, B, C, D, E, whatever. It depends on how many pins it has. Okay, so I told you we have here several ports. I told you the purpose of this chapter is to learn how can you program input-output devices here. I started last time with LEDs. I'm going to continue teaching how can you use the buzzer, how can you use the LCD, the keypad, the 7-segment as well, okay, and other input-output devices. I told you guys any input-output device has to physically connected here to this one here. Is that okay? And last time we used LED 0. You didn't need to connect it, okay? Because that's what this board is doing. So what this board is doing is that it's connecting this pin here, LED 0, is connected this one to the LED 0 here. Is that okay? So also I have explained to you before you use any pin, you have to configure, you have to initialize it as input or output. And I explain how can you do that. You have to write some instructions. Also, I told you what every instruction is doing for the hardware in order to make the pin input or output. Is that okay? Also, once you do the initialization, and this should be done only one time in your program, once you initialize the pin, input is going to continue input unless you change the configuration. That's why you need to do it only one time, the configuration, right? So if you have a loop, you don't need to put it in a loop because it's just you need to do it one time, okay? So also, I told you, if you have output pin, you should know. Let's see, what is the pin here? So if you have an output pin, also I explain how can you output here 0 volt, how can you output 5 volt using software by writing some instruction. You should know to do that, okay, how to do that, okay? Also, I explain if you have an input pin, in this case, there should be some circuit. There should be some circuit here. For example, I'm going to explain for sure. There should be some external circuit. The external circuit should put here 0 volt or 5 volt. And the microcontroller should be able to read, to know if this pin is 0 volt or 5 volt, okay? The last lab was practice for output. How can you program output pin? How can you program 0 volt and 5 volt? The coming lab is going to focus on input. How can you program one pin or 2 pins as input, and how can you read the voltage on it, okay? So yeah, I explained here the configuration. Also here, I told you here we have 4 LEDs as you see here. I explained how can we do flashing for the LED 0. And if I go back here, you can see that LED 0 is connected to P812. I'm right? Let's see. I don't remember. Yeah. So as you see here, LED 0, it's connected to B812. Okay. LED 1 is connected to BB0. LED 2, where is LED 2? Can you see it? Yeah, it's sorry, 3 is connected here to BB7. Okay, so we have we have 4 LEDs. Only 3 of them are connected here. The fourth one is not connected. Okay. Someone can ask me, so why is he put it? Simply because, as I told you before, this port can be used for 2 different types of processor. A small processor like ours. Also, it can be used. Where is the picture? Yeah. So as you see here, guys, you can connect here a bigger processor. You can connect it here. Okay. So that is why you will see some of the input-output devices here is not connected to our processor, but it can be connected to the other processor. But I'm going to tell you a trick if you want to use them. So that's what I'm going to explain today. So I told you already, LED 0, 1, 3 are already connected. You don't need to connect them. They already connected to our microcontroller. However, LED 2 is not connected. Okay. So I'm going to tell you, if you want to use them, what can you do? Okay, I'm going to tell you, very simple. What you have to do is that, so the LED 2 is not connected to our microcontroller. However, it is connected to this microcontroller somewhere here. I'm going to tell you where exactly. Okay, so all what you have to do, if you want to use this one, and that's what I'm going to explain today in some details. You have, for example, I want to connect this pin to this, you can select which pin you want to use. Okay, so I want to use this pin to connect it to LED 2. So you have to connect external jumper from here to where it is connected. So if this one is connected here, so you have to connect external wire this way, as I'm going to explain today. Okay, guys, and then after that you can use it. But anyway, so last time I explained this flashing LED. And actually what we did here, we just generated a square wave. So it's very easy, you can generate it. So if you connect the pin to the scope, you will see a square wave. And in the last lab, we generated square waves with different frequency, different duty cycle, and so on. And as I told you in the last lab, the time was too long. 1 second is too long for sure. 1 second was, or 2 seconds, or 4 seconds. All these numbers are too long, but still you can use the same lab. You can use small numbers like 1 millisecond, 2 milliseconds, small numbers. You can do it. However, I didn't ask you to do that in the last lab because we don't have a scope. If you connect to 1 millisecond, you will see the LED connected all the time, all the time. Is that okay? So if you have a scope, still you can use the same program and you can generate small signals or short time. Also, I explained last time, and the idea was very simple. You have to pull the pin high, and then you have to wait for some time and then pull it low. Okay. How can you pull high? How can you pull low? That's very easy. We have some instructions. This is an instruction for high. This is an instruction for low. And then you have to wait here some time. Okay, so you have to keep it high for some time. You have to keep it low for some time. So I also explain how can you make this time. If I want to keep it 1 millisecond, 2 milliseconds, 1 second, whatever, how I can do it. The way I did it, I created this function here. And actually this function is not doing anything. I'm just wasting time. So here, this function is gonna, this one here, you are gonna make for loop 136 times, and this one is gonna make 1 millisecond. So here, this for loop just because to make a full loop, you are gonna execute instructions. Okay, so the time is gonna be taken. The time taken to make 136 iterations here is gonna be 1 millisecond. So if I want to make a delay in millisecond, so I have to repeat this one n times. Okay, this is one way to make a delay. In the future, when I explain interrupts, I'm going to explain another way, which much better than this one. Okay, to make also delays. But at least for now, that's what you know. Okay, any questions, guys? Okay, now here also. I already made another program. Here, this one was flashing for LED 0. Okay, you already on the course website, you have programs to make flashing for LED 1. Okay, as you see here, guys, if you look at the code, I'm not going to explain the code anymore again, but because this code is just identical, it's the same thing here for this code, exactly same thing. The only difference is that for LED 0, I have to work on BB12. For LED 1, I have to work on PB0. That's it. This is the only difference. Okay, as you see here, I just make it in red. The changes I made it so PB0. So here I have to use port B. Here, you know, when I use shift, is a number I have to put here for which pin. Here I put 0. Here you have to enable GPI port B. Here you have to use B instead of using A. Here, okay, and also the shift is 0 because, okay, that's it. So you can see this program is just similar to the other program. I don't need to spend more time on this one, okay? This one similar to the other one. The only difference that here I just work with a different bin. Is that okay? Any questions? Yeah, sure.
The second line on the code on the right side, you were telling us we should use a temp variable so we never change the values directly, but it looks like you change it directly there. What's the difference with that command?
Okay. Okay, I'm gonna tell you what happened to me and why I'm doing this. I think my question is that here for this register, I can do OR this way. Here I can do AND this way. But the way for these registers, okay, here I have to read it first, and then I'm gonna do AND or on the variable, and then I'm gonna write the variable. Is that okay? Simply because when I try to do something like that here, the processor declined that. So it seems to me the hardware does not allow to do this operation on that. It only allows to read or write. You get what I'm saying? For some reason, the hardware is not allowing me to do that. You get what I'm saying? I know from software point of view, they are the same. There is no difference. Is that okay? However, for the processor didn't allow me to do AND this way or this way. It looks like you can only read or write. So here I read, and then it changes, and then I write it back. Okay. So this happened for me here in these registers, but this one was okay. You get what I'm saying?
So it's just a question of what the processor allows. Reason why that works, but
I don't know. The hardware didn't allow me to do it. Okay. So, but anyway, it's not a big difference anyway. So when I did it, it gave me error or it didn't work. That's why for this one, you can only read or you can write. So I'm gonna read, modify, and then write it. So it works this way. Yes.
well, we don't need that sequence.
Yes. Okay, guys. Then here I created a function. This function, I created a function just to make programming easier. You know, and this is a good thing and also bad thing about C language. Good thing and bad thing. C language, you can have functions to make programming easy. You can just use the function, but you can hide the details. You know what I'm saying? For example, if I want to turn an LED on, to me, this is details. You need to know which register, you need to know which port, you need to know which pin, and so on, this way, okay? So this is detail. So I can do the same thing, but using function. You get what I'm saying? That's what I did. So I did here, I created a function, it's called LED on. And then just send, you don't need to worry about the details. Just send the number here, which LED you want to turn it on. You want to turn number 0, 1, and 3. And then the details are hidden in the function. So if you see here, guys, in this program, as you see here, so here, and I created another one for off. So we have two functions here, one for on, one for off. On, whatever the number I send here, this is the LED number, 0, 1, or 3. On is going to turn. So here, what I'm doing here in this program, as you see here, guys, I'm going to turn LED number 0 on. I'm going to make sure number 1 and 3 are off. Okay, so so we have 3 LEDs. This one is on, and the other ones are off. Okay, and then I'm going to wait half a second. And then I'm going to turn this one off on, and these ones are off, as you see here. So number 0 off, number 1 on, number 3 off. I'm gonna and so okay. And then after that, after half a second, this one is on, these ones are off. Okay, and then I'm gonna repeat again. So you can see some kind of pattern. On, off, 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 on, off, and so on. You can see some kind of pattern here. So how this function works? Very easy. As you see here, guys, this function works this way. I'm gonna check what number you sent to me. If you sent me number first, this one is gonna make on. That means you have to use OR. Yes, because OR is gonna make it on. That's okay. The only difference is that based on the number you are gonna send here, I have to figure out which pin I have to use. And that's exactly what I did here. So here, if you send me number 0, so LED 0 is actually connected to B812. So I have to do this way. If you send me number one is connected to BB0, so it has to be this way. If you send to me number 3, so it has to be, it's connected to BB7, as you see here. Is that okay, guys? Okay. So I just hide all the this. You have a function. If you want to turn LED on, just send the number is going to turn it on. For the other function here, if you want to turn off this one here, okay, it's exactly, you can see exactly the same thing. The only difference is here I'm going to use AND. Okay, because I said before AND, and then if you put not here, so actually by this way you can turn it off. Any question here? You understand what I did? So all what I did, instead of using, again, sometimes to make programming easier, sometimes we need to somehow to hide details. Okay. The other one here I want to talk about, what if I want to use LED2? I told you LED2 is not connected. Okay. But still you can use it. So if you want to use it, you have to use a jumper to connect it. Okay. And what I did here in this program, again, guys, you have on the course website, you have all these programs. I tested them to make sure they are working. So all of them for sure they are working. Also, I made videos. Also, if you go to the course website, there is a link to YouTube. You can see all the videos I created for all these programs to show you how they work. Okay. So what I did here, guys, LED is connected to this processor here. So LED2 is connected here. You need to count from here to number 10. So 1, 2, 3, 4 until 10. So here, from here, the LED is connected to here. Okay. So if you want to use this LED, all what you have to do, you have to use the jumper. You have to use external jumper from here to which pin you want to use. It's up to you which pin. So here I decided for some reason to select BB1. Okay. So and I here in this program. So if by this way, you need to make a wire. You need to connect this pin to this here, from here to here. Okay. So here you have to count 1, 2, 3, 4, 5, 6, 7. So you have to count here 1, 2, 3, 4, 5, 6, 7. So this is the pin here, and then you have to connect a jumper from here to here. Okay, guys, external jumper, and then run it. The program should work. By the way, and also in the coming lab, as I'm going to explain, because there is no switches, the board does not have switches. So you have the red device, or the red device you had last time that have switches. Okay, in the coming lab, I'm going to show you how we need to connect it using also external wires. Okay, so anyway, so if you connect the wire this way, you can actually and run this program, it should work. Okay, so here I'm just explaining to you. If you go to the diagram, I already, you know this, I posted on the course website the schematic diagram for this port. You can see this is the processor. It's not our processor. This is this one here. You can see that LED2 is connected to this pin here. Okay, and I mapped from here to here. There is it took some time for me to figure it out because when I look at the diagram here, you find that this pin is number 11 from here, not number 10, number 11. However, I found that I think they don't connect this one. So I found that this one actually is number 10. When I put it here, it worked. So again, there is some inaccuracy in this file. This file is made by given to me from the people who need support, but I already figured it out. You understand what I'm saying? So if you wanna use this picture for any reason, you have to be careful. This one is not connected. So actually here, number 1 here start from here. Okay. So although LED here is connected, if you count from here, you are gonna go up 11. It's actually only 10. Okay. Anyway, that's what I figured. Anyway, so regarding programming, same thing, nothing is new. I don't need to spend time on this one. Everything is similar to what I explained before. The only difference is that you have to work on this pin. Which pin? This one, BB1. So all the initialization, everything has to be BB1, different from what we used to before, BA12, BB0, B7. This time is BB1. So you already have the program, you can see it. I don't need to spend more time on this one. I even even here in this program, I added here, when I added wire, so I added here also LED2. So as you see here, guys, here I'm going to use the four LEDs. I'm going to turn one of them on for half a second, and then the second one on for half a second, third one on for half a second, this one on for half a second, and then I'm going to repeat again. You have the program here. Also, this is I just also I modified, yeah, as you see here, I modified this code here so that I'm going to add number 2 here. And number 2, as I told you, again, nothing is new. The only here has to be PB1, and also for off has to be PB1. Any questions? This is the initialization. Again, nothing is new. This one is similar to what we did before. The only difference, this one is going to be initialization for PB1. Yes, sure. Okay, this was my selection. So, okay, let me put this one. I didn't select that LED. I didn't choose LED connected here because this is hardwired in the board. Is that okay? I didn't select that. However, port B, we already used port B here. Also, we already used port B here. You got what I'm saying? And when I selected, when I decided to connect this one, I just selected PP1 because this one is somehow empty. It's not, this one it's not connected to the speaker, it's not connected to the LCD. So I found this one is very appropriate one, because this one is not gonna interfere with the speaker or whatever. You know what I'm saying? So again, first of all, we already used port B. This is, all of them are the same. If you want to use A or B, it doesn't matter. You know what I'm saying? So, but the people who designed this board, they used PA12, PB0, PB7. When I had the choice, I just picked PB1. But I can select anyone else. It doesn't matter. Okay. So here for configuration, as you see here, guys, everything is similar to what is similar, but here I'm gonna work in PB1. Let me see if I have a video. I think I do, but let me see. I have a video for this one. Yeah, I think this one. Let me see. Yeah, but this one here, I'm using only 3. I didn't use so I didn't use this one. I used only 3. I'm not sure if I have another one for all of them. Let me see. Yeah, I think. Yeah, I just made it faster, I guess. Oh. Okay, let me start from the beginning. So as you see here, guys, I'm using only 3. I didn't connect a wire. As you see here, I did not connect a wire to use a LED2. Again, I was just playing. I think here the delay was 500 millisecond. I think I made it 200, right? Yeah, I made it 200 so that you can see it's gonna be move fast. You can see now, right? So it's moving very fast, right? Because I make a short delay. Also, I was playing. So I think I made it one millisecond to see what's gonna happen, I guess. Yeah. So if you see here, I'm gonna make it 1 millisecond. So I'm gonna turn one on for 1 millisecond, the other are off, and then I'm gonna turn the second one on for 1 millisecond, and so on. So let's see what's gonna happen. Yeah, this is very important thing. As you see here, guys, you can see all of them are on at the same time, which is not true. What I do, I turn one on, the other one off. One on, the other ones are off. But because I do it very fast, you will see it like all of them are stable. And this is very, very, very important, because I'm going to use the same idea later. We use the same idea in interrupters. In interrupters, we can do multitasking, as I'm going to explain later, okay? So your program is not going to be written in one place anymore. I have one task here, one task in the main, one task in the interrupt subroutine, one task in another interrupt subroutine, one task in one interrupt subroutine. And then I can run multiple tasks at the same time. How? Similar to this idea. So I'm gonna only, in reality, I'm gonna run only one task at a time, in reality. But if I can do it very quickly, you will feel like all of them are working at the same time, which is not true. You got what I'm saying? So by this way, very important, by this way, I can run the buzzer, I can run the signal segment, I can run many things at the same time. In reality, I only run one at a time. You understand what I'm saying? Similar to what I did here. We're going to have the same idea. I'm going to use it, what we call time multiplexing for the 7 segment. In the 7 segment, I want to display. I want to use here. I want to display a number here in the 4 7 segment. I'm going to use the same idea. What you have here 4. We have 4 7 segment. I'm going to put only this one is on, the other ones are off, and then this one is on, the other one's off, and then this one is on, this one is on, the other ones are off. If I do it very fast, you will see a very stable number. In reality, it's not only one is on. Okay, so this is very important to understand what we are going to do later. Okay, guys. Yeah, here again, it's look here, guys. It's the same program, but this time I'm using LED2. You can see I put a wire here. You can see the wire here. So you can see, look here, I'm using all of them. Okay, and I connect external wire. Anyway, I don't want to spend more time on this one. Yeah, look here, I connect external wire this way. Okay. Okay. So now, because I'm going to explain everything in this chapter, okay? But I'm not going to follow the same order here because I want to teach you first what we need for the labs, okay? So I'm going to skip this one here. I'm going to move to, so don't worry, I'm going to explain. This is my teaching style. I explain everything to students, okay? So everything I'm going to explain, but I'm not going to follow the same order here. I just need to teach what we need for labs first, okay? So far, guys, what I did, I give you, we already, I give you one example. How can you program one output device? Output device is the LEDs. We have 4 LEDs, okay? I explained them. So now I'm going to explain how can you program an input device. Input device. You should understand, as I said before, the difference between input or output device. Here, this is a microcontroller. If this one is output device, so the microcontroller you have using code, you are gonna put here 0 volt, or you can put here 5 volt. Is that okay? That's what we did actually. Okay. Now, if this is an input device, what should happen is that you have to connect, because this 0 volt or 5 volt is not gonna come from the microcontroller. You should connect here external circuit somehow. There should be an external circuit. The external circuit here should actually put here 0 volt or 5 volt. And then the microcontroller has to read the pin to see if it's 0 volt or 5 volt. That's it. So there should be some external circuit to put 0 volt or 5 volt. Is that clear? Let me give you details. Any questions? Okay. So what I'm going to teach now, and that's what we need in the coming lab. This is the focus of the coming lab. I'm going to teach, as you see here, guys, we have 4 push buttons. We have 4 of them, but actually only these 2 are connected to the board. To which pin? Yeah, as you see here, guys. So we have what we call a switch 4. We have a switch 5. A switch 4 is connected to BA5. A switch 5 is connected to BA6. Is that okay? This one, as you see here, guys, the first one here is called the switch 5. And this one is called switch 4. Okay, guys. This is actually, they call it a switch, but this is a push button. Okay, because I like to use. Okay, we have 2 different things you should be aware of. Number 1, push button. What push button is doing? Okay, so this is similar to the bell button in your home. Okay, when you ring the bell. So what happens here, guys, this is push button. Okay, and so what happens here when you press, you actually, you are gonna connect these 2 together. Is that okay? Once you release, there is a spring. It has a spring, so it's gonna be up here. You understand what I'm saying? So it's gonna connect only during the time you press. You understand what I'm saying? So when I press, you connect. Once you release, it disconnects. Okay? This is push button. Okay. However, there is something else we're going to use also in the coming lab, a switch. Here you have 8 switches. This switch is similar to this switch. You got what I'm saying? So here, once I go this way, you connect them all the time. Once I do this, you make it open circuit. Got what I'm saying? So here, what happens here, guys, is that it has two positions. This is one position. So if you connect this one, if you put this one at one side is going to be on, the other side is going to be off. Okay, so it doesn't have a spring. Okay, so once you connect it on, it's going to continue on forever. Once you until you change it for sure. Once you connect, so here this is one position, the other position is going to be this one. You understand what I'm saying? So for sure they are different, and the way I have to program them, as you will see, or the way I have to use them is going to be somehow different, as I'm going to explain. Okay, guys. So anyway, so this is, I'm going to call this one a switch. Unfortunately, the people who made the board also use the word switch for push button. Okay, I just want to differentiate between them. So I'm going to call this one a switch, but as the other one, I'm going to call it push button. Okay, so actually the chip you have here, or this, you have 80 switches. So everyone here, so as you see here, guys, everyone has one pin here and one pin here. So this is switch actually is gonna connect these two together, or is gonna make them open circuit. Okay, for the coming lab, we are gonna only use one of them. For sure, in the future or in your project or whatever, you can use more than one. Okay. Anyway, so I'm gonna, again, as I told you here, guys, the 0 volt or 5 volt has to come from an external circuit. Okay, you have to understand that. And now, so what's number one? I have to tell you how it is connected. Okay, so as you see here, guys, we have two of them, as I explained here. For the push button, we have two of them. How they are connected, again, I'm going to show it to you because maybe some of you didn't still know what I'm talking about. So if you go to the course website, guys, I post here in resources, I post here schematic diagram. So in this diagram should explain how this port is designed, how it is connected to the microcontroller. Is that okay? So I take some screenshot from here, from this one. Okay. So what happened here, guys? Yeah. So as you see here, these are 4, but as I told you, these two are not connected. These two are not connected to our microcontroller, but these two are connected to the other microcontroller. And also, I'm gonna explain how can you use these two. Okay. You still, if you need in your project or whatever, if you need, you can use these two as well. But you need to connect external wire, similar to what I did in AED2. Okay, guys? So, but let me first focus on this one. So again, although we are using this symbol here, but this is not a switch. Okay, this is a push button. So it's I don't like the way they draw it this way, because this means a switch. This one here anyway, but this means push button. But anyway, so this is a push button. This is another push button. Okay. So how it is made, as you see here, guys, it has a resistance here. It has a resistance connected to the ground. This resistor is 47K. So actually what happens here, you have a resistance connected to ground, 47K. And then we have here a push button this way. And then we have here, if you see here, we have this one is connected to another resistor, which is 1K and 5 volt. Okay. And then I'm going to take this one to go to the microcontroller. This point to the microcontroller. Is that okay? This is an external circuit. So again, you don't need to connect anything. As I said, this is how it's already connected in the board itself. Is that okay? So let me ask you a question. So if you have some little information about electronics circuit, tell me if I don't press the button, what voltage this pin is going to have. So this one actually, as I said, it's connected to, for example, if I talk about switch 5, it's connected to PA6. Okay. So if you don't press anything, this voltage here is going to be 0 volt. Is that okay? So normally it is 0 if you don't press. Once I press here, the current is going to go this way. And because this resistance is much smaller than this resistance, the voltage here is going to be close to 5 volt. Okay. So that means That means normally it is, again, this is how it is designed, okay? Normally it is 0 volt. The pin is gonna have 0 volt. Once I press, here you press, it's gonna go to 5. Here you press. Here you hold. Once you release, it's gonna go to 0 volt again. This is electronics. This is how the circuit, it's not circuit is connected. Okay, guys? So that means if I read this pin and I find it is 0 volt, what it means? It means you are not pressing. Okay? The switch is open. And then when I read it, I find it's 5 volt. What it means? It means you are pressing. You are pressing the finger. Any question? The switch. Push button. Any questions? Okay. So now, if I want to know if you are pressing or not, all what I have to do, guys, is I'm going to read the pin. If the pin is 0 volt, that means you are not pressing. Okay. If it's 5 volt, that means you are pressing it. That's it. Is that clear? Any questions? Okay. Programming wise, nothing is new. Programming wise, nothing is new, because all what you have to do, you have to configure, and I already explained it before. If you want to use switch 5 or push button, this push button, so you have to configure BA6. If you want to use input, you have to configure it input. Okay, I already explained how can you do that. If you want to use a switch 4, you have to configure this one is input. Okay, then if you want to know if you are pressing the button or not, all what you have to do, and this was my question in the quiz in the last week. You need to check what is the value of the voltage here. Any questions? I'm going to show you how can you do it. Okay? So yeah, that's what I'm explaining. You should again, guys, please. So the coming lab, we are going to use a switch. We are going to use push button. You should understand what is the difference between a push button and the switch. Push button, it's going to be, as you see here, we always 0 volt. Once you press, it's going to be 5 volt. As you hold, it's going to continue 5 volt. Once you release, it's going to go to 0 volt again. Okay. That means if I read the pin and I find it's 0 volt, that means you are not pressing. If I read it and find it's 5 volts, that means you are pressing, and so on. Okay. Okay. So this is here what I did here, guys. I did a program. This program should reflect the value on a switch 5. So if a switch 5, so what this program is doing, so I'm gonna read switch 5 is connected to PB what? Switch 5 connected to, sorry, BA6. So here what I'm gonna do in this program, I'm gonna read the value of BA6, I'm gonna reflect it on LED 0. Okay. So if there is a 0 volt here, so I'm gonna put 0 volt here. Okay. If there is 5 volt here, I'm gonna put 5 volt here on LED 0. Is that okay? That means if I run the program here, that means normally the LED is off. The LED is off because I'm gonna put 0 volt. Once you press, I'm gonna turn it on. Once you release, it should be off again. Okay. So okay. So number 1 here, I explain how can you do initialization. I don't need to spend much time on this one. I already explained it. So you need here, you need to enable port A, and then you have to do all this initialization as I explained before. Once I do, I just put it in a subroutine so that my program is going to be organized. Once I do that, as you see here, guys, in while loop, see what I did here in while loop. In while loop, as you see here, what I did is I'm gonna check, and I already explained this one before. I'm gonna explain it again here. As I said in chapter 2, I think I explained it 20 times. So it started from chapter 2. If you want to check one bit, so here, if I want to know all what I need to know, guys, here, PA6, there is, as I said before, there is some connection, hardware connection between the pin and a register. This register is called IDR. So at any time when this one is 0 volt, this one is in this bit, you are gonna see logic 0. Anytime you put here 5 volt, you are gonna see logic 1 here. Is that okay? So all what I need to do, if I want to know if there is 0 volt here or 5 volt, I want to check this bit. That's it. So that's exactly what I did. How can you check this bit? Okay, as I said before, I'm gonna put here 1, then I'm gonna put 0 everywhere. Is that okay? And then I'm gonna do logic AND. And then I'm gonna check the result. If the result is 0, that means this pin is 0. Otherwise, it is 1. Okay, and that's exactly what I did. Look how I made it here. So this is the register. This is the bit. This is the bit I wanna check. So what I did here, I put here 1 and then I shifted 6 times because I wanna check bit number 6. So the 1 has to be here. Okay, and you know why? Okay, so I'm gonna put here 1 and 0 everywhere, as you see here, and then I'm gonna check if the result is equal to 0. If the result is equal to 0, that means the pin here 0 logic 0 here. If there is logic 0 here, that means the pin has 0 volt, right? So in this case, if this is the case, so I'm gonna turn the LED off. So I'm gonna write here in LED. The LED is actually connected to BA12. So here I'm gonna write 0 to BA12. Otherwise, I'm gonna write 1 to BA12, as you see. Any very important. We'll go to all the time. Any question? Especially this part. Any question here? Raise your hand. Very important. We'll do it all the time if you have any questions. There is something tricky, and somehow that's how C language is. Look here, guys. Someone can ask me why you put parentheses here. What happens if you don't put parentheses here? Okay. Actually, what happens, you know, in C language, we have some kind of priority for operation. This operation should be done first, this is second, third, and so on. The way they did it in C language is this operation has more priority than this one. You got what I'm saying? So if you don't put parentheses here, it's tricky. It's tricky. If you don't put parentheses here, what's gonna happen is that this operation is gonna be done first. And the result of this one should be 0 or 1, based of this true or false. And then we're gonna do AND. Okay? For sure, that's not what I wanna do, right? I wanna do AND first, and then I wanna compare to 0. That's why I put parentheses here. So I put parentheses here because I need to do this operation first, and then I compare it to 0. If you remove it in C language, this one has more priority, this one. So what's gonna happen, this one will be computed first and then AND second. For sure, that's not what I wanna do. Do you understand what I'm saying? Any questions? It was, when I first taught this course, I had this, it's somehow tricky because, you know, any logic or mathematical operation should have more priority than equal, right? This one should be. But anyway, they don't do it this way in C language, okay? Anyway, so any questions? So based on this program, guys, what should happen is that normally this LED 0 should be off. Why? Because the voltage here is 0 volt. Okay, so it should be off. Once I press, so actually the pin is going to jump to 5 volt, and the program here is going to turn the LED on. Once I release, the LED is going to be off. Again, you have the program here, you have the board, you can play it with it in your home. Also, you have videos here for, I think I made videos almost for almost all programs. All programs, yeah. So I made videos for all of them. So as you see here, guys, normally it is off when I press the button. So it's going to be on. Once I release, it's going to be off again. Is that okay? Any questions? Is that okay? Good. Now, I'm going to explain a very known problem. We call it bouncing problem. This is a known problem in any mechanical push buttons. Any mechanical push button suffers from this problem. Okay. So actually, what I told you is what I told you guys is when I press the button, that's what I told you, right? So when I press the button, it should be high, and then once you hold, it should be high. Once you reach, should go to low. That's what I told you. Okay. This is actually, this is an ideal switch. This is not in reality. In reality, it's not going to be this way. Why? First, in reality, how it's going to look like in reality, and why? So if your switch is ideal switch, if your switch is an ideal switch, that's what you should see. You have to see the signal this way, okay? However, we have what we call bouncing problem. In reality, you have to see something like that, okay? What happens is that, as you see here, once you press the button, there should be some kind of ripple, high, low, high, and low for a very short period of time. That can be like 5 milliseconds or 10 milliseconds, very short, okay? And then here you hold, once, same thing, once you release, it's not get, once you turn it on, it's not gonna be on right away. There should be some bounce here. Once you turn it off, also there are some bounce here until it becomes zero. So that's what we call bouncing, okay? So again, what I'm saying, any mechanical switch, you imagine or you think is this a signal has to be this way. In reality, it's not going to be this way. In reality, when it changes its status from 0 to 5 or 5 to 0, there is some bounce, as you see it, bouncing. Okay, bouncing. You know what I mean by bouncing? I'm going to tell you what it is. For example, you connect these two contactors together. Okay, bouncing means why I have 5050. Why? Because the switch is gonna open, close, open, close, open, close. As I told you, when you open, 0 volt. When you close, 5 volt. Okay, so what happens, because you have a mechanical switch, so because you have a spring, any mechanical switch has a spring. So what happens, the spring is gonna make some kind of very quick. You might not even observe it because just in 10 milliseconds. Imagine 10 milliseconds, very short period of time, right? So because this is the nature of springs or something mechanical, okay? So what happens, as you see here, and also as you see here, guys, same here. So what happens here, you are going to have some bounce in this way, okay? It's not going to be this way, it's going to be something like that. Okay, guys? So this is something nature or something normal in any mechanical switches, okay? So now the question is that, okay, you are telling us I'm expecting something like that, but actually I'm going to get something like that. That's true. Okay, what's the problem? Is there a problem? The answer is yes, there is a problem. And you need to explain to me what's the problem and how we are going to fix it. That's what I'm going to say. The problem is that, look here, guys. The problem is that microprocessor is very fast. Yes, this one can be 10 milliseconds, which is very short period of time, but microprocessor is faster than that. What's going to happen is that you may not observe in this program, in the program I taught right now. But for example, if I connect this signal to interrupts, for example, as I'm going to explain later, you are going to create a trouble. You are going to have a problem. Okay. What problem is that? I'm going to tell you what's the problem. The problem is that although here you press only one time, right? You press one time. However, because the processor is fast, the processor will think that you pressed 3, 4, 5 times and it's going to take action 3, 4, 5 times. Why? When the processor is going, so every pulse here, every couple of pulses here, the processor will think you press release, you press release. So for example, if you have a program, if I press one time, the processor has to take one action, right? However, if the signal is this way, the processor is fast, the processor will think this is one press, one press, one press, one press, one press, one press. So maybe when you press one time, the processor is going to take it like you press 3, 4 times. For sure, there is no human being, or it doesn't make any sense that human being can press 3, 4 times in 10 milliseconds. You get what I'm saying? So this is the main point. No one can, you cannot make presses, you cannot press 3, 4 times in 10 milliseconds. That's a pretty short period of time, right? So anyway, so this is the problem. The problem is that microprocessor is very fast. So microprocessor, if you don't solve this problem, what's going to happen? You press one time, you want the processor to take one action, but what's going to happen? The processor is going to take 3 or 4 actions. Why? Because the processor will think you made one press, one press, one press. You every time, so it's going to take it like you press 3 times. You understand what I'm saying? Number one, you understand what bouncing means? You understand why it happens? It happens only in mechanical switches because of the spring. You cannot just open this way. There should be some bouncing before this contact is gonna come here, this one. And again, this is a very short period of time. So you should understand why this is a problem. Okay, or how this can create a problem. So if I connect this one to interrupt, to make only one interrupt, you are not going to make one interrupt. You are going to make 3, 4 interrupts every time you press. So the processor is going to take it. Is going to think that you press 4, 5 times again, because processors are very fast. So processor is going to come here to check. You find, yeah, you did one press here, you did one press here, you did one press here. Okay, guys, any questions? Okay, for sure that's a problem, right? Because you press one time, you want to take one action. What's going to happen? The processor is going to take 3, 4 actions. Okay, how can we solve this problem? There are 2 ways to do it. There are 2 ways. The first solution, we call it hardware solution. Hardware solution. There is some also software solution. I'm going to explain both of them. That's what we call deep balancing. So you need to solve the balancing problem by doing deep balancing. Okay. So for hardware solution, what we can do, guys, you can just connect a capacitor this way, as you see here. You can connect a capacitor this way. Why? I'm going to tell you why. What happens is that when you have some kind of balance in this way, look here, guys. So when it is high, so actually the capacitor is going to charge. Once it is low, the capacitor is going to discharge. And because the time, this is a very short time, the capacitor is not going to charge too much. So as you see here, guys, as you see, I will see something like that. Here, when it is open, it's as you see here, open, closed, open, closed, open, closed. When it is open, you are going to charge. Is that okay? And then closed, discharge. In the second part, second ripple, you are going to charge, discharge. Is that okay? However, because the time is short, you are not going to charge too much to be taken as high, right? Keep in mind, low or high has a certain voltage range. For example, just an example, from 0 volt up to 0.3. Any voltage here will be taken as zero, logic 0, right? 5 volt, for example, until 4.3, for example, okay? Any voltage here. So as long as you are in this range, you should be okay. As you see here in this figure, guys, because the balancing, the time is too short, that it cannot charge too much. So you are gonna see here, it is low. Yes, the voltage is gonna increase little bit, but it's still it is low. Any questions? So this is one solution to the rebel problem. You can connect the capacitor this way, so that this capacitor is gonna increase the voltage little bit. Charge, and still it's gonna be considered 0, logic 0. Okay, guys. This is, I'm not sure if they did it in the board or not, but anyway, for peace of mind, I will try always to have the software solution. So if you face any trouble, try. It's up to you. If you write your code and you find it's not working very well, it may be because of the bouncing problem, and in this way you can put the software solution. So what is the software solution? I'm going to tell you how we can do it. Look here, guys. Once I find this one is high, okay, so I'm going to write this instruction and this instruction and this instruction. Okay, so using these 3 instructions, okay, I'm going to do deep balancing. What do you mean by deep balancing? It means when you press one time, the processor is going to take it one time, not 2, 3, 4 times. Okay? So as you see here, once I find it is high, so I'm gonna make a delay for 20 milliseconds to just bypass this period, this period of time. You can try different numbers here, but anyway, so here you can it shouldn't be more than 20 milliseconds, should be more than enough anyway. So you can write different numbers here. So number 1, once I find the pin is 5 volts, so I'm gonna wait 20 milliseconds to bypass this period, this time, and then as you see here, guys, I'm gonna wait until you release here, as you see here. So I'm gonna say as long as does not equal 0, that means 5 volt. So I'm gonna keep looping here. I'm gonna wait until you release. Once you release, I'm gonna wait another 20 milliseconds. After that, I'm gonna take action. So this is only one press. After that, I'm gonna take action. So let me say it again. What I'm saying, guys, is that once I find it is high, I'm not gonna take action right away, okay? Because if you take action right away, It may be another rebel here. You are going to take action here, I take action here, which is not true. So what I'm gonna do, once I find it high, I'm gonna wait 20 milliseconds, as you see here. Then I'm gonna wait. I'm gonna make a while loop here. I'm gonna wait until you release. So I'm gonna take action after you release. Okay. Even after you release, I'm gonna wait 20 milliseconds. After that, I'm gonna take the action. You got it, guys? In your program, you have to write this one, and then after that, you can take the action. Yeah, you press one button, you take the action. Any questions? Good. Look here, guys. Now I'm gonna talk about the switch. How it is different? Exactly, I'm gonna repeat exactly the same thing. But there is one difference. What is the one difference? Look here, guys. I told you very important difference. Here, if in case of push button, what's going to happen? Here you don't press. Once you press 5 volt, it's going to be this one. So once you press, it's going to be 5 volt. Once you release, it's going to be 0 volt. Is that okay? However, the switch is going to behave differently. The switch is going to behave differently. The switch has two positions. In one position, so if you connect the switch, as you see here, guys, the switch has two, it can be here or it can be here, two positions. If I connect it to one position, I'm going to get 5 volt. For how long? I don't know, until you change the position. So once you change the position, it's going to be 0 volt. You understand what I'm saying? So the switch has two positions. One position is going to make open circuit, another position is going to make short circuit, similar to what we have here. So this switch is making open circuit. That's why the light is off. This switch is gonna make a short circuit. That's why the light is on. You understand what I'm saying? Completely different from push button. Is that okay? So here, all what you have to know, if I want to know if the switch is connected to this position or this position, all what I have to know, just I need to check what is the value, what is the voltage here. One position is going to give you 0 volt. The other position is going to give you 5 volt. You understand what I'm saying? And now, if you use this switch, any system should have on-off. Any system should have a switch for on-off. You want to turn the system on, you want to turn the system off, whatever system, what kind of system you have. So I can use this one for a system. If you have a system, I want to turn the system on, I want to turn the system off. So all what you have to do is that I need to know, I'm going to consider one position. Again, this switch can have one of two positions. One position is going to give me 5 volt, one position is going to give me 0 volt. I'm going to consider one position on, the other position, I'm going to consider it off. So all what I need to know now, in order to take action, either turn the system on or turn the system off, all what I need to know, the position of the switch, where the switch is connected, right? And in order to know the position of the switch, all what I need to know is the voltage. So now, as you see here, guys, this is how we can connect the circuit. You can see the way I connected this circuit is identical, similar to the way the push button was connected. It's similar, okay? So here, that's why last time I give you resistors. Last time in the lab, I give you resistor. So this is the way you have to connect it, guys, okay, in the coming lab. Because again, the board does not have switches. So you have to connect it externally here. You have to put the switches here. This switch can, this package, okay, it has 80 switches. For sure, we're not going to use 8. We're going to use only 1. Okay, so you are going to use this pin and you are going to use this pin. Okay, this pin is here, for example, and this pin is here. Okay, and all what you have to do, you have to connect the resistor, one resistor this way, one resistor. As you see from electronics, from circuit and electronics, as you see here, guys. If the switch is open, this is one position. So here we are going to get 0 volt here. The microcontroller is going to get 0 volt. However, if the switch is connected, again, there is a current here, and this voltage is going to be very high voltage because this resistor is much less than this one. So it's going to be 4.5 or whatever. So this one is going to be high, 5 volt or high. You know what I'm saying? So I think that's what I told you. There should be an external circuit. This external circuit should put here on the pin, microcontroller pin, either 0 volt or 5 volt, high or low. right? So as you see here, if this one is open, I'm gonna get 0 volt. If you close it, you are gonna get 5 volt. Okay, guys. So that's what you have to do in the lab. Externally here on the breadboard, here, you already have one K, you have 47K, and you have to connect the switch. How can you connect the switch? That's very easy, guys. As I told you, just use any one of these. We have 8 switches here. You just use any one of them. And one pin is here, the other pin is going to be here. Someone can ask me, okay, so how I can get 5 volt and how I can get ground? So if you look here in the board, you can find in several places. For example, you have ground here. So you can take ground from here. Also, you can find here, here you can see 5 volt. You can take it from here. So you can find several places here. You can see 5 volt, and you can see also 0 volt. So you can, yeah, it's here. So you can see 5 volt. And let me go to the picture. No, it's not here. Yeah. So if you see here, guys, yeah, you can see. Look here. You have this pin is ground. This pin is 5 volt. Ground and 5 volt. Okay, so you can see, you can find here you have 2 ground here. So you can find in several places you have ground and 5 volt. Okay, so what you can do, you can connect the ground, for example, to here. You can connect. Where is 5 volt? I'm not sure if there is one closer than this one. I think this is the closest one. So yeah, you can connect 5 volt from here to here. Okay, sorry. If you do that, you make short circuit. Connect it to here. Okay, and then you can connect the switch this way, both resistance, and then after that, you need to connect it to a pin, right? So that's what I'm explaining here. Yeah. So you need this one here. You need a jumper to connect it to one pin in the microcontroller. Is that okay? Which pin? Again, it's up to you. So here I selected PB1. So again, don't ask me why PB1. just I try to find one that does not interfere with other devices, so that in case if you want to use multiple devices at the same time. So I just selected PB1 here. You can use any other one. Okay. So again, all what you have to do similar to what we did here for BE6 and BE4, BE6, same thing. You have to configure BE1. You have to configure PB1. You have to configure it input, and you have to connect it this one to the circuit, and then you have to read it. That's it. So all what I did here, guys. I'm gonna also show you the video. So what I want to do here, guys, as you see, I'm gonna use switch connected to PB1 to LED 0. What it means? It means, again, similar to the program I have just taught right now. This is PB1. All what I need to do is that, in one position of the switch, you are going to put 0 volt. In another position, you are going to put 5 volt. Okay. So all what I want to do right now is, if you put 0 volt here, if there is 0 volt here, so the LED, I'm going to make it off. If you put 5 volt here, so the LED is going to be on. So in one position of the switch, I'm going to turn the LED on. In the other position, I'm going to turn the LED off. What I'm saying? That's what I want to do. So number one, similar to what we did before, I don't need to explain it again. You need to do configuration. Here in this configuration, you have to configure PB1 input. You have to do configuration this way. And then this is the program. Look how I made the program here, guys. I'm gonna check this bit. PB1. PB1 means this bit. So I need to check this bit. I have to put here 1 and 0 everywhere, as you see here. So here I'm gonna check this one. If I check this one and I find the result is 0, that means this one is 0. So if it is 0, so the LED, I'm gonna put 0 to the LED. Otherwise, I'm gonna put 1 to the LED. And it's just, I'm gonna make it loop. Why I'm making it loop? So that at any time, it's not only one time, it's inside the loop. At any time you change the status of the switch, actually what I'm doing here, I'm reflecting, I'm echo. So here I echo the status of the switch to the LED. If the switch in one position, LED is on. Okay? Always. If it's in the other position, LED is going to be one position on, one position off. Any questions? So for the coming lab, it's exactly the same thing. Maybe I change the LED. So you have two tests. One test is this one, but it has to be one program. This program, you have to use a switch to show the status, to reflect the status switch on one LED, right? Also, in the same program, you need to check push button to reflect the status of the push button to the LED. I'm gonna talk a little bit about the push button, but for the LED, for the switch, almost the way you have to do it in the coming lab is gonna be similar to this one. Maybe I made minor changes. Instead of LED 0, I think I asked you to make it LED 1. Not a big difference, right? Instead of connecting it, I don't remember. Instead of connecting the switch to VB1, maybe I asked you to connect it to another pin. Everything else will be the same. You understand what I'm saying? So for this task, it will be exactly, in the coming lab, it will be exactly similar to this one, but maybe I make minor changes. Because this one is for VB1, maybe I made another pin. This one LED 0, I think I made it another LED 1 or something like that. Okay. So I'm going to choose a video to understand better what I wanna. Again, you have all the programs, you have the board, you have the videos. So just you need to play with them. Okay. Yeah, look here. So as you see here, guys, let me go to the beginning again. As you see here, guys, I have a switch, I have resistors. As you see here, I connected the 5 volt here, and I connected the resistance. I connected this resistance to 5 volt here, and then to one switch, right? And then I have another resistance here. Again, I'm using 2 because I had different resistors than what you have. In your case, you have to use one here, one and one. Okay? But here I didn't have these resistors. But anyway, and then ground, as you see here, ground is here. So you need to connect. You need to connect the switch, one terminal of the switch, to resistance to 5 volt. The other terminal here, I'm using this switch, only one switch. The other one is connected to resistor, the resistance. You don't need to make series this way. I made it this series because I didn't have the value, the resistor I need, right? So I got 2, I made it series. Anyway, then I connected this one to the ground. And then this one here, it should be connected to the microcontroller, okay? As you see here, look. As you see here, it's connected from here to the microcontroller. You know. Please don't use any external power supply for the 0 volt and 5 volt. Okay, as I told you, the board already has 0 volt and 5 volt. Okay? So now you see the switch, the LED is off because the switch in one position. In the other position, yeah, look here, I'm showing you, this is the ground, okay? Yeah, I'm showing you, I got 5 volt from here. So I just want to show you how I connected. So look, I got the 5 volt from here. I connected to here. So I'm here, I want to show you how I connect. And then you have a wire, as you see from here to okay. So now the switch in one position, it is 0 volts. That's why you see the LED is off. I'm gonna change it now. Look, it's just very little. That's why I'm using a screw. So once I turn it on, so this switch is gonna put here 5 volt. The program is gonna read the 5 volt and turn the LED on, as you see here. And it's gonna continue on. Big difference between this one and the push button. In the push button, when I press on, once I release, it's off. What I'm saying? Because this is how push button works. But here, it's gonna continue on. Okay, guys, any questions? So, in the coming lab has 2 parts. The first part is going to be almost like this one, but maybe I change it so just the pin, I change the LED, but it's going to be exactly similar to this one. But the push button, the second task of the push button is going to be different from what I did. Little bit different from the program I explained. The program, little bit. The program I explained is when I press, this one is going to be on. Okay? When I release, off. No, I don't want to use it. I want to use the push button as on-off switch. What do you mean? I mean, if you have a system, in this case, our system is just an LED. There is something very simple. Okay. When the LED is, when the system is on, when I press one time, I'm going to make the system off. It should continue off. When I press again, the system should be on and continue on. That's what I'm saying. Again, look what I'm saying. You have a system, and you want to turn this system on and off. Is that okay? That's exactly what I did for switches. That's what I did. The switch has two positions. I'm going to consider one position for on, one position for off. So all what I'm going to do, I'm going to read the voltage. Is the voltage 5 volts? So I'm going to take action to turn the system on. If the voltage is 0 volts, I'm going to take action to turn the system off. Is that okay? Push button is different. Push button is different. Okay, let me explain it here because this is very important. What I'm saying, guys, if you have a system, again, here in our case, the system is LED, something too simple. The future can be something complicated. But anyway, you have a system. This system can be on or off. Okay. If you use a switch, this is an easy case because the switch has two positions. In one position, it's going to give you 0 volt. In one position, it's going to give you 5 volt. So all what I need to do in order to decide to turn the system on or off, all what I have to do, I'm going to read the voltage. If I find the voltage, for example, 5 volts, so I'm going to turn the system on. I'm going to turn the LED on. When I find it 0 volt, I'm going to turn it off. Is that okay? You understand what I'm saying? However, this is for LED. This is for a switch. However, the push button, the story is different. In case of push button, look here, guys. So here, every time I press, I'm going to make a pulse like this one. So initially, the system is off. Initially. So when I press here, I have to, or initially it is off. When I press, so the system has to be on, and it has to continue on. When I press again, the system has to be off, and it has to continue off. When you press again, the system has to be on, and it has to continue on. You understand what I'm saying? So this time, I should not rely on the voltage. This is different case from here. Here, if I want to know if the system should be on or off, I'm going to just depend, or I'm going to just measure the voltage. I'm going to see if it's 5 volt. Here, I should not do that because here I have 0, but the system is on. Here I have 0, but the system is off. What I'm saying? So you should not rely on the voltage. So what should I do in this case? If I want to use what I'm explaining right now, guys, is that how can use a switch as on-off for a system, whatever the system is in the coming lab, so just an LED, right? But still, you can use the same idea for if you have a bigger system. Also, I'm explaining push button is not going to be as straightforward as a switch. Okay, what should I do? What you have to do, very simple. Look here, guys. You have to use a variable. You have to use a memory variable. Okay, memory variable. This variable should, whatever the name you want to call it, you want to call it status, you want to call it on off, whatever variable. This variable should take one of two values, for example, 0 or 1. I'm gonna consider, just give me 1 second. I'm gonna consider 0 means off. I'm gonna consider 1 means on. Is that okay, guys? So all what I have to do is that, listen to me. All what I have to do, initially the system should off. That means the variable should have 0, value 0. Is that okay? And then, in order to turn the LED on or off, I'm gonna check the variable. If the variable is 0, so the LED is off. If the variable is 1, the LED is gonna be on. You got what I'm saying? Also, inside the while loop, I'm gonna check the pin here. If the pin is 0, if this pin is 0, that means okay, I don't need to do anything here, nothing, do nothing. However, if it is 1, all what I'm gonna do, if the variable is 0, I'm gonna make it 1. If it is 1, I'm gonna make it 1. You got what I'm saying? So you need to have a variable in order to reflect, in order to capture the status of the system. So every time I press, you are gonna change the variable. And then if I want to turn the system on or off, so I have to check the variable. You should understand what I did here. You should understand why this is different from case of switch, because in case of switch, 2 positions. One position is going to give you 0 volt, one position is going to give you 5 volt. So all what I have to do, I'm gonna read the pin. 5 volt means on, 0 volt means off. That's very simple. Here, it's not going to be this way. So all what I'm going to do, I'm going to use a variable. This variable should take one of 2 values. Okay. Every time I press, so I'm going to switch. If it is 0, make it 1. If it is 1, make it 0. I'm going to check. Okay. And then if I want to make a decision, either turn the system on or off, I'm going to ask the variable. Okay. So how can you do that inside the while loop? So you have to have while loop here, infinite while loop. Number 1, you have to check the pin here. If it is 0, do nothing. Okay, do nothing. If it is 1, so now I have to flip or I have to change the variable. If it is 0, make it 1, 1, make it 0. Is that okay? So this is the first part I have to do in while loop. Number 1, I have to check. Number two, you have to check the variable. And based on the value of the variable, I'm gonna turn the LED on or off. Is that okay? Also, inside, this is one task. The second task should be inside, I'm asking for one program. Inside the while loop here, and this is the easy one. So here, this is for one task. The second task, I'm gonna check the pin of the switch. If it is 0, so the corresponding LED is gonna be off. If it is 5 volts, the corresponding LED is going to be on. And then this should be continuous. You understand what I'm saying? Continuous in while. Again, my advice to you guys, you can start with my programs first. So you have the software, you have the board, you have all my programs. I'm sure they are working. You can start with this program, understand them, and then you can modify them to do